So my name's James Borders. I actually just joined BU this summer, so I was thrilled to get an invitation, really excited to be here. But I'm going to be talking about cough dysfunction in Parkinson's disease. So we know that aspiration pneumonia is a leading cause of death in PD. Its development, though, isn't driven solely by swallowing dysfunction, so material entering the airway, but instead is the result of the combined effects of swallowing and cough dysfunction. So if someone can't produce a strong, timely, and effective cough, they're not going to be able to clear their upper and their lower airways to maintain a healthy pulmonary environment. So what we're looking at here is an X-ray of a person swallowing with PD. They're swallowing barium, which is shown as a dark contrast. And what you'll notice is that we kind of see two profiles of cough dysfunction. One here where the material is entering the airway, but there's no cough immediately in response to it. Whereas this second clinical profile, there is a cough response, but it is not timely and it's not effective. So material is still entering the airway. So there's been this fundamental debate about whether cough is a strength or a skill-based behavior. There are several reasons why we're starting to think that cough is more of a skill-based behavior in PD. So first, the primary pathogenesis of PD involves the coordination of multiple subsystems. So its primary pathogenesis is characterized by impairments in motor control and coordination. We also know that cough requires precise temporal coordination across distinct phases, so inspiration, compression, and expiration. And then recently we've learned that cough is actually highly modifiable, especially in PD, and it's not considered a purely reflexive behavior. But despite this, most studies have focused on strength-based approaches that are targeting and really trying to bolster the respiratory system. And we found that these confer relatively minimal benefits and are not a key driver in predicting treatment gains. So to this end, we've developed skill training paradigms to rehabilitate cough dysfunction that target specific sensory and motor aspects of cough with the ultimate goal of promoting motor learning. So we've investigated through our kind of preliminary data, looked at different treatment parameters, so the influence of visual biofeedback, the structure of different practice conditions, and providing different levels of sensory stimulation during the training. But essentially, they're shown their cough airflow on a computer screen, and they're trying to hit different targets. But these interventions are pretty preliminary at this point and really lack a unified mechanistic framework. And they also fail to offer guidance on neural mechanisms that are really underlying and supporting these treatment gains. So to this end, we developed a conceptual model whereby higher order cortical processes mediate sensory motor cough function. So the next step in our work is to interrogate this model to understand the role of the cortex in cough upregulation, particularly in populations with reduced cough function like PD. We further hope to identify task conditions that promote cortical reallocation, like the effects of cueing, attentional focus, and somatosensation, and also look at differences in cortical processing between healthy older adults and PD. So we're kind of noticing a trend here. We are also going to be hoping to use FNIRS to investigate and look at cortical activation, but that's kind of where we're moving from here. Thanks so much.